Hi, welcome to our channel. Good news. The Chinese semiconductor sector began to gain a footing in the new global market reality 7 months after the US government put limitations on SMIC International Corporation, China's largest pure foundry manufacturer. Despite being effectively excluded from the latest semiconductor manufacturing tools required to catch up with global leaders such as TSMC, major Chinese chip manufacturers, including SMIC, continue to develop 14 nanometers and 12 nanometers FinFET process nodes using mature deep ultraviolet lithography toolsets and processes, which account for the majority of semiconductor production today. SMIC sees an opportunity to focus on these mature silicon processes, which may boost output and hence have a stronger influence on the company's bottom line. Indeed, Zhao Haijun, the company's co-CEO, once stated that, based on strong customer feedback on its 14 nanometers process capacity, SMIC has chosen to expand its spending by $1.1 billion to $4.3 billion in order to fulfill the demand for chips in communication and automotive applications. We anticipate that China will be entirely self-sufficient in 14 nanometers technology by 2022. Registrations of new indigenous semiconductor businesses in China have quadrupled since early 2021. Possibly providing a solid domestic market for chip-making services such as SMIC, according to the South China Morning Post. The government, which is pushing China to become self-sufficient in silicon manufacturing that year, is essentially driving China's semiconductor sector. This ambition has suffered a significant setback as a result of U.S. restrictions prohibiting U.S. technology exports to Chinese firms. But we believe that Chinese industry may still build chipsets based on more advanced process nodes. Despite the utilization of cutting-edge methods to generate sophisticated silicon required for high-performance computing and artificial intelligence, worldwide market demand for chips based on older silicon technologies remains robust. For example, the semiconductor shortage affecting the automotive sector is mostly due to a lack of mature silicon processing capacity, since many aging fabs departed early in the pandemic. We think that around half of worldwide semiconductor expenditure goes to mature process chips, thus China's capacity to establish a vibrant and thriving semiconductor sector remains a very real prospect, with or without official backing. China Mobile has entered the sector by establishing its own chip-making company, Xiancheng Tech, which would specialize on chipsets for Internet of Things, IoT, devices. It intends to modify and strengthen its existing IoT business unit, which now has over 850 million connections, by using its own IoT chip design. The world's largest wireless operator is aiming to bring silicon design in-house, which bodes well for the future of Chinese semiconductor production. Furthermore, China's Vice Premier Liu He has launched a program aimed at using the country's semiconductor manufacturing capabilities and skills in order to position China as a prospective global leader in compound semiconductors. These are chips made from materials other than silicon, including as silicon carbide and gallium nitride, which are widely utilized in radio frequency components used in 5G devices. The Chinese government sees compound semiconductors as a potential to become a worldwide leader since they do not rely on cutting-edge chip production. This concentrated government effort has previously proven effective, and Vice Premier Liu believes that China can carry it off with the proper support. As leading-edge process nodes get finer, only a few firms with enough scale can afford to invest in new process technologies that cost billions of dollars. The global semiconductor manufacturing sector has been divided. TSMC, Samsung, and Intel are among the companies with the scale to lead the effort to push Moore's Law to its breaking point. However, enthusiasm in consistently investing in cutting-edge process technology has reached its limit for foundries other than the Big Three. Global Foundries, the world's third biggest pure-play foundry, Intel is still considered a captive foundry, has postponed investment in process nodes below 12 nanometers in order to focus on tackling global silicon shortages. Similarly, Taiwan's fourth largest foundry, UMC, and SMIC see chances with current process technologies that are more in demand, generating less motivation for these foundries to keep up with the hefty capital expenditure required to be on the cutting edge. many non-market pressures are added into what would otherwise be ruled by the free market as the US and China engage in increasingly severe geopolitical trade battles. However, political realities cannot be avoided, and the most recent trade moves have pressed China's hand in its pursuit of semiconductor independence. But, as with many business issues, there is a silver lining in every cloud. China's goal of semiconductor self-sufficiency continues as the country focuses on creating a stable, robust, and healthy silicon ecosystem capable of supporting an industry dominated by foreign competitors. Shanghai Tianshu Zhixin Semiconductor Company claims to have developed China's first 7-nanometer chip, which is characterized as a cutting-edge, general-purpose cloud computing processor based on a proprietary GPU architecture. The data center processor, dubbed Big Island GPU, is touted as a neural network training chip intended at AI and HPC applications as well as general-purpose computing at the cloud server level, according to Tianshu Zhixin. While Big Island was billed as China's first 7-nanometers training chip, the fable's business did not say where it was manufactured. Previously, Chinese chipmakers were thought to be at least 2 generations behind cutting-edge process technology. Taiwan Semiconductor Manufacturing Company manufactures the majority of 7-nanometers devices, NYSE, TSM. TSMC is mentioned as a partner on the Chinese company's website, among prominent chip design software companies such as Synopsys and Mentor Graphics. Other hints point to the chip's manufacturing origin. Tianshu Zhixin's Big Island chip has 24 billion transistors and is packaged in a multi-chip packaging method termed a 2.5 chip-on-wafer-on substrate, which was initially introduced by TSMC. The packing approach, among other benefits, dramatically increases memory bandwidth. NVIDIA's a 100 ampere-based GPU, on the other hand, has 54 billion transistors on 826 mm2 of silicon, making it the world's biggest 7-nanometers device. Big Island's peak speed is 147 teraflops of 16-bit floating-point performance. It has high-speed connectivity and facilitates multi-precision, mixed data training. Other numerical forms supported by the new GPU include FP32, 32-bit integer, and float 16. The data center GPU is also targeted at solve-ing, the fundamental computer power computing problem, according to the Chinese chipmaker, implying that the business hopes to compete with industry leaders NVIDIA, NASDAQ, NVDA, AMD, NASDAQ, AMD, and others. Big Island also claimed that it can finish the artificial intelligence processing of hundreds of camera video channels per second, and the performance is double that of popular solutions on the market. The 7-nanometers GPU chip's development began in 2018. According to sources, the item was initially rolled out in May 2020, and volume manufacturing is slated to begin this year. Along with AI-based video processing, Big Island will be used for applications ranging from autonomous driving to medical research, according to the firm. Tianshu Zhixin stated that it aims to make consistent development throughout the whole product cycle, and create strong and steady preparations for large-scale manufacturing and market launch of future goods. The Shanghai city government and Taiwan's VIA Technologies formed a joint venture to create the fable's chip producer in 2013. Thanks for watching in this video. You can add your ideas or suggestions below. Please keep following our channel and like our videos.